Guys, we now do this question of control, and guys, I can read the question. Define loop, sync, forward path, and then figure shows a signal flow graph. Obtain CS over RS using Mason gain formula. So guys, the first thing we want to define is the loop. And I use the diagram for that. For the loop, for example, now guys, here we have a loop. So when we define it, you can say it's a path originating from a node and adding up to the same node without traversing any node twice. That is the loop. Sync. Guys, as you can see, the sync is right here. It's actually a node that has only incoming branch. Then guys, we have the forward path. Forward path is actually this path from this RS up to CS. You can also go through this G4 and then go to CS. But for the definition, you can say it's a path that originates from the input up to the output without traversing any node twice. So guys, that is the forward path. Guys, now we come to the question of the finding CS over RS. So guys, I have already done that question and I can show you now right here. So you can see guys, now we use what we call Mason gain formula. First guys, we identify the forward path gain. The forward path gain is given by this path, that is the path through G1, G2, G3. This is G3. That is one of the path. And the other one is through P2. Is P2, path P2, which goes through the G4. From this point it goes out like that up to the output. That is the path, another path. So we have the path gain as G4. The Mason gain formula, guys, it states like as shown. This is P1 delta 1 plus P2 delta 2 all over delta is equals to now the transfer function. So guys, we have already found the P1 and the P2. Now guys, we go ahead and now look for, before we go to the delta, we look for the loop gains. For the loop gains, guys, we have only two loops here. One of the loops is this, which is G2, G3 multiplied by 1. This is now supposed to be illustrated by G2, G3. Then we have another loop here, G1, G2 and negative. So negative 1. So this is our loop. Coming now to the delta, first we begin with the delta. Delta is equals to 1 minus the loop gains. The loop gains are this, plus non-touching, this is NTLG is non-touching loop gains taken 2 at a time, minus non-touching loop gains taken 3 at a time. Guys, as you can see in our case, we only have loop gains. We do not have non-touching loop gains. And so therefore we work with that. Now for delta 1, here we have delta 1. Delta 1 is equals to delta when path 1 is removed. Guys, if we were to remove this path 1, we remove the node, we remove the branches. Guys, you will find that we shall have no loops. And so therefore, it's going to be 1 minus this 1, that is for the delta 1 is going to be 1 minus 0 because we don't have any loops after we remove the path 1. Coming now to this, the delta, guys, we should have started with the delta. where we have 1 minus the loop gains. The loop gains are actually here. So that one we have done. Then for the delta 1, we have 1 minus 0, where we are saying if we remove path 1, we will have no loops left. And so therefore it will be 0. Coming to delta 2. Delta 2, we are saying it's equal to delta when path 2 is removed. Guys, if we were to remove path 2, which is this path along here, you find we shall be left with these two loops. And so we shall say it is 1 minus these two loops. And it is now given here. This is 1 minus the two loops, G2, G3, and this G1, G2. We put the bracket here, this is minus. And so therefore, guys, now we come to the equation. Our equation here, as we have seen, is actually for finding the control, that is the control ratio, or CS over RS will be P1. We write P1, we write delta 1, which is 1. P2 we write, and delta 2 we've already been given, and the delta we have. And this is now our solution, guys. You can see this is the P1, then you have a 1 there, P2, and then this is the delta 2, 1 all over 1 minus, this is 1 minus, we write it well, that is 1 minus now the loop gains. And so therefore, guys, this is our solution. Thank you guys for listening to me. Bye bye.